as India takes a leap into the space-based assets, we have Mr. Jagan from TSC Technologies. Thank you very much for your time, sir.
Thank you so much.
We would like to know what is TSC Technologies highlighting in Aero India 2023.
Absolutely. Thank you so much for having us here. And what we are showcasing here are two products which are primarily into the aerospace side of it, and in the IDEX pavilion we have the defense side of our products. And in the aerospace side of it, we can start with the 0.35U. We already have 3 of these satellites in orbit as we talk, and these essentially form a constellation. The constellation is formerly referred to as the UnitySat constellation. So these are essentially communication satellites which track and report asset locations, and they can also be used for IoT kind of applications. So starting from the 0.35U, we are now migrating to a 1U platform. And the systems that we are building for the 1U platforms are scalable up to a 6U and then a 16U. With a 1U platform, we would be demonstrating the capability of doing multi-frequency transmissions, inter-satellite communication, and also Earth to satellite, satellite to satellite, and satellite to ground data relay. Right? And the speciality of this system that we have is the communication payload itself will be able to do beamforming. Typically beamformings are done when you have a larger satellite, but in this case we are able to do beamforming even with a much smaller satellite like a 1U platform, and it is one of a kind because we are doing beamforming in a UHF platform and specifically within this small 1U platform. Apart from this, the 1U platform also has individual card, we call it the beacon, which you can refer to as a satellite within a satellite. Right? So it has its own power supply, it has its own monitoring system or the OBS system, and we also have its own communication system. And that's the antenna that you have for the beacon itself. Okay. So these antennas are going to be deployed as beryllium copper strips. They would be rolled in and then it would be deployed. So in the event of the deployment mechanism failing, right, most satellites fail at that point. So in order to overcome that, what we have done is we have come with a unique way of putting a Rigiflex antenna as part of the beacon structure itself. And as the satellite is going to be loaded to the deployer, this is how it's going to be loaded. Okay. And the moment it's going to be deployed in orbit, without any external deployment mechanism, that's going to be deployed this way. Right? Which means even if the main satellite fails to deploy, if the antennas fail to deploy, you would still have continuous transmissions to let us know what has really happened on the satellite, which is again unique for a small satellite like this.
So if I had to ask, a lot of startups these days, along with already established companies which are focusing heavily on beamforming technology, and also their future plan is to get into information warfare, build some assets for us.
Yeah.
How does TSC's these products which are highlighted right now, how do they differ or they stand as a unique asset in space?
That's an excellent question, and that kind of naturally leads us to the next step that we are looking at. So like what you rightly said or asked in terms of beamforming as being one of the principal technologies that many startups are looking into. As I said earlier, most of these beamforming is done with a really large array of antennas, right? But you need to start at some point. We can't say that we would be doing beamforming only when we get to a 12U platform. So in order to build the capability, we start even from a 1U platform, right? And so that's why we are starting from a 1U platform and doing beamforming right from the 1U platform. And these are our future products that we have in MAP. So this is going to be a Earth observation satellite. These are COMET and LN kind of application satellites that we have. And in fact, here you can also look at the other satellite that we are proposing. It's a 16U satellite. What is unique about this satellite is typically when a satellite is doing a SAR imaging, it is expected that the satellite would be looking at an angle, right? Because you need a swath, and these are typically at an angle that the satellite would be looking. And in order to achieve a co-located imaging satellite, it would not be possible without doing beamforming. So what we are doing is actually to put a camera, a hyperspectral camera, and also have these large antenna arrays that would do the beamforming required. So even though the satellite is looking down this way, the formed beam is going to be scanned on a other angle or at an angle.
How has been the response of the end users so far with regards to the current satellites in space?
So there's a lot of interest that we are able to generate right from the schools to the universities, now actually even with the Air Force and the Navy and the Army as well. There have been a lot of interesting questions that are being put to us in terms of what are the capabilities and what is the smallest factor that can still be able to do a larger communication payload or a defense related payload. So those are things that we are currently looking at. Okay, so what we are showcasing in the IDEX Pavilion are the defense challenges that we have won as part of the DIS 7 challenges. So we are building 4 products which are unique in a lot of aspects for the Indian Navy. One of the products is the portable RCS measuring device that we have here. So a typical RCS measuring device is something which is quite bulky and it's a full-fledged radar in a lot of sense. Right? One of the downsides of having such a big bulky system is that you don't have the flexibility of moving around the target. So this is fine if your target is a cooperative target, right? If it's your own vessel that you are trying to take an RCS measurement, it's fine. But if you are trying to take an RCS measurement of a foreign vessel, then that wouldn't be possible. So that is why we are making the whole system, which is typically half the size of this room, into such a small form factor, and which is going to weigh less than about 10 kgs or less, right? And the whole system is going to be standalone. So it comes with its own display, its own processor, user interface, and its own amplifiers and the transmitter and the receiver part of it, which can be mounted onto a tripod for land purposes, can be mounted on a boat, or it can even be mounted on a drone. Right? So once we mount it on a drone, then you can actually see the RCS measurements that you can probably take. Right? So this is what end user would see on a desktop application. So you can actually see the measurements taken for a ship, and you can actually see how the measurements are going to be displayed to the end user. So apart from the measurement, we are also thinking of putting together a video recording capability and an IR recording capability, so that you will be able to build a detailed 3D model as well as an IR model of the vessel or of the target of choice. Right? Okay. So that's something which is unique that we are doing.
Have you proposed the system to the Navy already?
We had proposed this as part of the DIS solution, DIS 7 challenge. So we are one of those contenders who have been selected to implement, and we are in the process of submitting the prototype.
How do you look at the export market from this Aero India?
That's a very interesting question, because yesterday we had very detailed discussions with chiefs of or air chiefs of multiple countries. We spoke to about 5 of them yesterday, and there's certainly interest. To name a few countries, we see interest from Singapore, we see interest from Myanmar, and also Egypt, who want to take such technology and deploy it for their own applications as well. So that way, the whole IDEX platform and the Aero India platform has been very great in terms of opening up access to newer markets, which is typically a challenge for a startup.
For the final question, how have you been looking at your infra? What are the current developments which you all have made?
Right, so the way in which we are classifying or looking at our infra is basically to start looking at from the RF side of it, and also to play with our strengths, which is essentially the electronics and the RF, what we have built over time for the satellite and the ground station, and we are focusing more in terms of AI and other emerging technologies as well.
Artificial intelligence is now integrated.
Yeah, so one of those examples would be this device here. So it's actually a underwater camera.
Okay.
So we essentially have stereo cameras here, and artificial intelligence, a processing unit in between, and a display unit in the back. Right? So it's in a very small factor. It can feel a little heavy at this point, but once you get into water, this is going to be neutral buoyant.
Oh, thank you very much.
Yeah. Thank you so much. See you.